If you want to learn Spring and you really want to master Spring Boot, the very first place you've got to start is with developing an understanding of what dependency injection and inversion of control is all about. When the Spring framework was released way back in 2004, that's how creator Rod Johnson described it, as a dependency injection and inversion of control container. Since then, a number of projects have sprouted from the Spring framework. We've got Spring Data, Spring Web, Spring AI, but at the core remains that dependency injection and inversion of control container. And that's what this tutorial is all about. I want to show you how to create a simple Spring framework application that just uses the core Spring context libraries. I'm not even going to use Spring Boot in this application. And I'm going to show you exactly how you can use the Spring IoC container to manage the lifecycle of Java beans that you create, and even inject in to the Java beans you create some of the Java beans that Spring IoC container is managing for you. Now, I've said a bunch of words that sound intimidating, are scary, or you don't know about. Don't worry, because we're going to cover each of them right from the start over the next few minutes that we're together. And I guarantee you, at the end of this tutorial, you're going to be an expert. You're going to be exceptionally dangerous when it comes to the ideas of inversion of control, dependency injection, Spring, and the Spring Boot framework. Hi, I'm Cameron McKenzie. I'm the editor-in-chief over at TheServerSide.com, and I have to be one of the world's biggest Spring and Spring Boot advocates. And that's why I've put this tutorial together. I'm seeing more and more people using the Spring framework to solve their enterprise problems, and I want people to have a fundamental understanding of how Spring works so that solving those enterprise problems becomes a little bit easier. We're going to start off with the discussion of inversion of control, what it is, how it works, what the term means, and that is what we're going to deal with next. Now, the first thing you have to promise me is that you're not going to get intimidated by the term inversion of control. It's actually a deceptively simple concept, and all the inversion of control principle says is that when you're developing an application, you should focus on keeping your business logic lean and clean. And that means if you've got components with complicated life cycles, manage those life cycles outside of your business logic. If you've got components with complex configuration, parameterize, configure those resources outside of your business logic. Push that to an external framework like Spring. And if you have to interact with subsystems, if you've got low-level coding that you have to do, that's just going to muddy up your business logic as well. So push those types of functions outside of your business logic into an inversion of control container, into a framework like Spring. That's it. Keep your business logic clean and push complicated tasks outside of your business logic into an external framework. That is the fundamental concept behind Spring and Spring's inversion of control container. Now, I'd actually like to go into, I've got the Eclipse IDE installed here. You could have any IDE, VS Code, IntelliJ. I want to create a basic Spring project, not even Spring Boot. I've got Spring Tool Suite installed here. I'm just going to create a simple Maven project that references the Spring core context libraries. I'm going to create a class, and I'm going to make that class managed by the Spring IoC container so that we can see how the Java beans we create and the Spring container work together. And then after that, we'll move into dependency injection. So starting off, I'm just going to create a brand new Maven project here. I'm going to say click that button to create a simple project and skip the archetype selection. I'm going to call it com.mcnz.spring as the group ID, Spring Framework as the artifact ID. That all looks good to me. I'm going to click Finish. And then I'm going to head over here to mvnrepository.com and get the Maven coordinates, the Maven Gav for the Spring context. The Spring context gives me Spring Core, and it also gives me all of the resources required to do inversion and control and dependency injection with Spring. It's really one of the most minimal configurations you can get. Now, by the way, I did do a tutorial on how to install Spring Source Tool Suite and a tutorial on how to create your first Hello World Spring application. So if I'm moving quickly here just at the start, feel free to check those out. Otherwise, feel free to just click pause and rewind and take a look at what's going on here. But dependencies has to be added. And after dependencies in there, I just paste in the coordinates that I had copied from Maven Central, fix all of the annoying things that have been added here by the tool, and boom, all of a sudden this looks good. Now, by the way, I do believe that sometimes you end up getting an error in your code there. Is that because that should be HTTPS? Yeah, maybe that's it. I don't know how to get rid of this project one, but hey, that's Maven for you. The point is, I've added a reference to the Spring context to my code, and after doing this, I always like to just do a run as Maven install, and that's just going to force all of the dependencies to come down onto my local file system. Now, fundamentally, all I've done here is I've created a Maven project that has a reference to the Spring framework in it. I'm going to close that Maven POM file, head over here into that Java folder. By the way, if you want to see what libraries get added when you link to the Spring context, you can actually take a look at them by opening up that Maven dependencies there. So that's kind of interesting. But I actually want to start creating some code. So I'm going to create a brand new Java class. I'm going to put in the com.mcnz.spring package, and I'm going to call it Spring Framework. Why not? Because we're just going to concentrate on inversion of control and dependency injection with the Spring Framework. And I'm going to add in that main method there. Now, the goal here is to create a Java bean that can be managed by the Spring Inversion of Control container. I want to create a simple class. I'm going to call the class Score. And eventually I'm going to work towards building a rock, paper, scissors game. If you follow through on all of these Spring and Spring Boot tutorials, you'll see a rock, paper, scissors game created. And of course, if we're going to create that, we need to keep track of the score, which will just be a listing of the wins, losses, and ties. So I'll declare those variables in the score class. A couple of points here, not adding setters and getters, because I'm just going to keep this simple. So feel free, report me to the authorities, but I think it's just going to be nicer for learning to have the code clean. Secondly, if you're doing this on your own at home, or you're writing an enterprise application, you put each class in its own file. There is a rule in Java that says you can have one file, one Java file, and it can have one public class, but it can have many non-public classes in it. So I'm going to put all the code into one file here just to make it more obvious to see what's going on. I hope it makes learning a little bit easier, even if it's not modeling the best software developer behaviors. So I've got a class called Score. Now, normally when you create a class, or you want access to a class, or you want an instance of a score class, you would do something like, say, score equals new score, right? Use the new keyword, call a constructor. But we're going to imagine that the score class has, let's pretend it has complicated configuration, or let's imagine that it has complicated lifecycle management requirements. I mean, it doesn't, but let's pretend that it does. If that's the case, well, have the Spring IoC container manage it, manage its lifecycle. And how do you do that? Well, in this code, I'm going to first just create an instance of the Spring framework, declare an instance of the Spring framework. And the technical name for the Spring framework is ApplicationContext. Usually the variable name is just context for the application context, but I'm just going to call it Spring just to emphasize that it's the Spring framework. And from here, I'm just going to say, let's create a new, the actual class that we're going to create is the annotation config application context. Is that the name of it? Annotation config application context, and do Control-Shift-O, see if it imports in. That's it. So application context is an interface. That's actually a concrete implementation of it. This is good for reading annotations, which we're going to use in the future. One thing I do need to mention is when you create that application context, you actually have to tell the context what classes you're going to manage. There's a few different ways to do that. The easiest way is just to put the name of the class that you want to manage in that constructor there, and boom, all of a sudden that Spring framework is going to be managing instances of that score class for us. Now, what does that mean? Well, that basically means that when I want an instance of the class, well, I don't create an instance myself. Instead, I ask the Spring framework for it. So I can do something like this and say score equals Spring, not new score, but score equals Spring dot get bean. And which bean do we want? Well, we want the bean that's associated with that score class. So this now gives us an instance of that score class. And now I've pulled that score class out of the application context. I've pulled that score class out of the Spring IoC container. The Spring container creates the instance for me, so I don't call the new keyword. I don't call the constructor. The container does that for me. You see, that's the inversion of control. I don't control creating instances of it. I've asked another part of my program. I've asked an external framework to do it for me. That is the inversion of control. I don't control the lifecycle management. That's been inverted. Spring now does it for me. But of course, this is just a score class like any other score class. So I could say score.wins++, and then print out system.out.println score.wins. And if I run this application, well, of course, we know that Java class, when it's first initialized, the properties go to 0. So before we increase the wins by 1, the wins should be 0. After we do the ++ and print it out, boom, it goes from 0 to 1. And now all of a sudden, my basic Spring application that has a single Java bean being managed by the IOC container is all working, is all running. And you're getting your first taste of creating this Spring application context, the Spring IoC container, having it manage a bean, and then pulling that bean out of the container and then using it in your code. That is the first step to understanding inversion of control. Now, the next step is giving us a little bit more insight on what managing the lifecycle means. And that is what we're going to take a look at next. So some people will look at this little example and think, you know, why did we do spring.getBean? What's the benefit to that? And for that matter, it seems like a lot of work just to get an instance of the class that we could have got simply by calling the constructor. So one of the things I like to do is I like to contrast the idea of just calling a constructor to the concept associated with inversion of control and getting a Java bean from the container. And to do that, I'm going to need a for loop, or as the Primogen says, a boomer loop. But right now, instead of getting the score from the IOC container, I'm going to say score equals new score. So I'm just going to create a basic score object. I'm going to increase the number of wins, and then I'm going to print out the number of wins. And I'm going to do this 5 times. So I'm going to say surround with a for loop, and it's going to be I is less than 5. You know what? I'll do all sorts of advanced tutorials, and the most comments I'll get is on the fact that I just did that surround with for loop. People's minds are blown when you do that. But let's take a look at this code. I've creating the score using the constructor. I've got a loop where I'm going to do this 5 times. Each time I increase the number of wins and print out the number of wins. So, okay, so let's say run as a Java application. And what do we get? We get the number 1 each time, right? Because every time we get the score, every time we create a new score instance, well, you know, the values of wins, losses, and ties are set to 0. Then we add 1 to the wins, print it out, but then we create a new one again after that. So that's what happens if we use the constructor. But watch this. What do you think happens now? So instead of managing the life cycle on our own, we're inverting control of the management of the score class. We're inverting control of the management of the bean we created. We're giving the rights to do that to the Spring framework. Now, instead of creating instances on our own, we're going to say the Spring framework, give me an instance of the score class. We're going to do it inside a loop 5 times. Now remember, previously when we ran this using the constructor, we got 1, 1, 1, 1, 1. Save my code, click run, and now look what we get. 1, 2, 3, 4, 5. So something's happening here. Something interesting is happening here. And one of the things that's interesting that's happening here is when the Spring framework provisions an instance of the score class, what it does is it creates an instance of the score class behind the scenes, but it caches it. Okay, it puts that one instance into a singleton pattern, and it makes sure that anytime somebody wants access to the score, everybody gets the same instance. Okay, so if you've got thousands of methods here trying to gain access to the score, we're not going to have thousands of instances created in memory. Instead, we're just going to have one. It's going to be very efficient. It's going to allow all of the pieces of code to share that same common instance. Implementing the singleton pattern is essentially what it's doing there. Now that's interesting, right? It could have done the opposite. It could have implemented a factory pattern. A factory pattern creates a new instance each time. It doesn't do that. Spring is an opinionated framework, and it says, we have opinions on the best way to do this. And we think by default, anytime we work with a Java bean, we should implement it using the singleton design pattern. So only one instance is ever created. By the way, you can do some configurations and tell it to set it as a prototype and create new instances each time. But the point is, by default, it's actually managing the life cycle of this object in a very, very interesting way. So, people sometimes say, I don't see the value in doing this. Why? Well, behind the scenes, the Spring framework is doing a lot of things for you. This is just one example. But as you use the Spring framework and use inversion of control more and more, you'll find more and more tricks and more benefits for using the inversion of control container. Okay, that is the deep dive on IOC. Next, we're going to take a look at dependency injection, taking our example one step further. So Spring bills itself as a inversion of control and dependency injection container. We've taken a look at the fundamentals of inversion of control. Now let's take a look at dependency injection. So first of all, what is a dependency? Well, a dependency exists when one Java class references another Java class through an instance level property. So we've got the score class. You could imagine that we might actually have a class in our problem domain called game, right? We're going to have a game class. Maybe we're modeling a rock, paper, scissors game or something like that. And the game class is going to keep track of the score. I don't know, probably have a method called play the game. I don't know what happens. We'll make everybody a winner, right? When we play the game, the score.wins gets increased by 1. I don't know, just do something crazy there, right? Everybody gets a car. Everybody's a winner. But the idea here is that game class has a dependency on score. So we've got a class called game. It is a dependency on score. Big deal? Maybe, maybe not. Well, normally when you write code, you create instances, and when a class or a component that you're using has a dependency on an instance, you provide it. But we want that score class and that game class to be managed by the Spring IoC container. So I add that into when I create the context. And now the Spring container is going to manage both the game class and the score class. Now, how do we actually initialize that score class inside of the game? Well, I guess, maybe if you wanted the score class, you could do, something like this, score, get score, and then, increase the number of wins, something along those lines, right? You could figure that, get that to work. You probably have to initialize the application context. But first of all, that would be incredibly messy. And secondly, yes, the inversion of control container is managing the score class. Yes, the game class needs an instance of the score. And yes, the game class could directly go to the application context and ask for that score. But one of the goals of inversion of control, one of the goals of the Spring container is to make linkages between your code, your business logic, and external services, external libraries. Make that a decoupled link. Make that minimize the linking to external frameworks. We want a loosely coupled application. So the idea that we would use the Spring framework to create a loosely coupled application that doesn't directly reference external libraries, but at the same time directly reference the Spring library, which is comprised of thousands of lines of code, that would be nuts. It would be, it would defeat the purpose. So Spring says, you know what, I get it. I'm managing all of these classes, but your Java beans, your business logic should be clean, and it shouldn't even have a reference really to the Spring framework in it. Instead of trying to get a bean out of the application context, what we'll do is anytime you have a class that's managed by the Spring framework that has a dependency on another class managed by the Spring framework, for that dependency, you can just put like an auto-wired annotation above that dependency. And when the code runs, the Spring framework will take a look at that game class as soon as it gets created the first time. It'll see that it depends on an instance of the score class, and the Spring framework will create the instance of the score class, create the instance of the game class, pass the score class to that game class, give that game class that instance of the score class that it created, and then it will run your code. Remember, inversion of control, right? The Spring container is taking care of creating objects and even initializing properties of those objects. Initializing properties of those objects is dependency injection, and is taking care of all of this for you so that all of this work is alleviated from you, and it's doing this in such a way where you never in your code actually directly reference the Spring IoC container. One of the ideas of an IoC framework is that the framework will call your code when needed. Like behind the scenes, it's calling the constructor of our score class and the game class in order to create them. But you shouldn't be directly calling in your code the framework, right? That's the difference between a library and a framework. A library is a set of APIs that you call. A framework is not something that you call. Instead, the framework calls your code. It's called the Hollywood principle. Don't call us, we'll call you. Now, by the way, I do have an error there. Do you see the red X? If you see the red X there, you need to get your eyes checked. That is actually a white X on a square, on a red square. But either way, if I do Control-Shift-O, organize my imports, the auto-wired annotation comes in, and now that score class is going to be auto-wired into the game when this runs. Now, I'm going to mess around with my code up here. Of course, I don't need to get the score directly anymore. What I'm interested in, I'm actually interested in that game class, right? So I'm going to delete a few lines of code here, and I'm going to actually come in and get the game class, game equals, I'm going to get the game class from the Spring IoC container. So spring.getBean, game.class. Okay, so that looks good. So now I am getting that game class from the Spring IoC container, but that game class has a dependency on the score. The score is also managed by the container, but we're going to ask that container, look, just inject that right into the code. I don't want to have to put any references to that framework, to the IoC framework inside of my code. And so now with that done, we could say game.playTheGame. And in theory, that should increase the number of scores by 1, the number of wins by 1, score wins ... So why don't we print that out? System.out.println. And we could say game.score.wins. And in fact, you know what? I'm gonna call play the game twice. Let's get away from the number 1. Number 1 could just happen serendipitously, but a 2. 2s are always intentional. Okay, so let me take a quick look at this. I'm going to delete that line of code right there. One thing you should notice is that our Java beans, our components are very, very clean, right? They're just focusing on business logic. We don't, in our application, even have to worry about calling constructors. The life cycle of the beans are managed for us. And when I've got one Spring managed bean that has a reference as a property to another Spring managed bean, that dependency, when using an auto-wired annotation, will be fulfilled by the Spring framework at runtime. We can get dependency injection on that score property that the game class has. Okay, now, will all of this work? If Spring isn't working, we'll get a null pointer exception because maybe that score object wasn't initialized. If we get the number 2 printed out, well, we've got inversion of control and dependency injection and everything else working like crazy. And there we go. Boom, we end up getting the number 2 printed out. And there you go. That is inversion of control. So breaking it down, what is inversion of control? Inversion of control is this design principle that says if your application's business logic has complicated lifecycle management of certain components, has components that have high levels of configuration that are required, or even there's a lot of connecting to low-level subsystems, get that the heck out of your code and push it into some external framework that can handle that code better for you. Just concentrate on your business logic. Now, the other big thing about inversion of control is it's supposed to keep your business logic clean. It's supposed to keep your business logic pure and keep your business logic loosely coupled so that you don't have a lot of tight dependencies on components and layers and libraries. Now, again, we can get our components directly out of the Spring framework, but we don't ever want to directly reference the Spring framework in our code because that would defeat the purpose of loose coupling. So instead, what we can do whenever we have one class that has a dependency on another class that's managed by the Spring framework, we can just do dependency injection. And that allows us to get components from the Spring IoC container without ever having to actually reference that IoC container in our code. So we get all the benefits of inversion of control, but we never actually pollute our code with a direct reference to the framework that you're using. Remember, that Hollywood principle, we'll call us, or we'll call you, don't call us. What's the Hollywood principle again? Don't call us, we'll call you. Forgot that for a second there. Now, there you go. Now, by the way, I will say, right here, we've actually used what's called field level dependency injection. There's also setter injection, and there's constructor injection as well. Constructor is actually what you're supposed to be using, and setter is a good backup for some corner case situations. I've got a subsequent tutorial that covers that, so please go and take a look at that tutorial next. Another thing that I would say is a lot of people call me out on that auto-wired annotation. They say to me, you know what? You said that your code has to be clean of Spring, but that auto-wired annotation is actually part of the Spring framework. There's a couple of ways to even get those annotations out of your code. One way is to use a Spring configuration class. Another way is to use an XML file where all of your configuration happens. And I've got tutorials on both of those, so please check those out as well. And there you go. That is everything that you need to know to get started with dependency injection and inversion of control with Spring. Now, if you enjoyed that tutorial, I want you to head over to TheServerSide.com. I'm the editor-in-chief over there. We've got lots of great tutorials on Spring, Spring Boot, RESTful web development, Git, GitHub, Agile, Scrum, you name it. If you're interested in my personal antics, you can follow me on Twitter at CameronMCNZ. And also, I've got a couple of books behind me there. So Hibernate Made Easy, What is WebSphere That Doesn't Sell Too Well These Days, Pickering and Springfield, which is a little book on The Simpsons, and then also Darcy DeClute at Scrumptious on Twitter, her certification guide for Scrum. I helped do some of the final edits on it, so pretty proud of it. A lot of people are purchasing that Scrum Master certification guide and scoring 100% on the exam and on the product owner exam, so if you're agile and working with Scrum, check that out. And then finally, if you're watching this tutorial on YouTube, well, why don't you subscribe on YouTube?